Okay, in this section 4-10 we're looking at exponential and logarithmic models part 2. And so this is part 2 of the lesson that we started from last time. Now remember, last time we did take a look at the 5 types of models that we were dealing with. And so we have the same models back here again, so we'll be dealing with these same 5 in this section. And remember, what we did last time was we practiced taking the equations and the graphs and trying to match the equation to the graph, and then trying to match the equation and the graph with which model is being used. Alright? And so again, we have all of the 5 different models written back out here for us, because we'll be using them again in this section. And so in this section now, these are the type of problems that we're going to be faced with. So let's read through it. It says, in a research experiment, a population of fruit flies is increasing according to the law of exponential growth. So right there, they're telling me which one I'm using, exponential growth. Okay? And so this is the equation that we're going to be using. After 2 days, there are 100 flies. After 4 days, there are 300 flies. How many flies will there be after 5 days? All right. Now, remember, when you're looking at this equation, that the x and the y, those are your variables, right? And x is number of days, y would be number of flies. Okay, so y is the number of flies after x amount of days, and that's the exponential growth. Now the a is a constant that we don't know, e is a constant that we do know, and b is also a constant that we don't know. So here's what our strategy is going to be. We're going to use the 2 sets of data that they've given me to write 2 equations, and we're going to use those system of equations to solve for the a and the b. Once I solve for the constants a and b, then I can plug those back into the original equation and use that equation to see how many flies there'll be after 5 days. So that's kind of an overview of the strategy, and so here's how it works. Okay, so let's use the first one first. After 2 days, there will be 100 flies. All right, so remember, the number of flies is y, so it's going to be 100 equals a e to the 2b power. All right, because after 100 days, there's going to be, after 2 days, there's going to be 100 flies. So 2 goes in for x, and 100 goes in for y. And then b times 2, of course, is 2b. So that's where that comes from. Now, let's write the equation from the next set of data. After 4 days, there are 300 flies. So that's going to be 300 equals a e to the 4b power. Okay? Because once again, b times 4 is 4b. So remember, the number of days goes in for x, and the number of flies goes in for y. Alright, so now we've got a system of equations that we need to solve. So you've got to think back to Algebra 2. How do you solve a system of equations? Well, you need to rewrite one variable, okay, in terms of the other. So I'm going to take the first equation and write it for a in terms of b. So then I can take this and substitute it in for a and have a new equation all in terms of b. So let me show you what I mean. So we're going to solve this for a. Okay, so in order to solve it for a, then I can divide both sides by e to the 2b power. When that happens, I have a equals 100 over e to the 2b power. Okay? Now, I've rearranged this and solved it for a in terms of b. Now, remember, our whole goal is to get an equation with just one letter, one variable in it. So I can take a out and put this in its place, which is in terms of b. Then I will have an equation with just all b's in it, and I can solve it for b. So that's what we're going to do now. We're going to substitute 300 equals to a, take a out, put what it's equal to in its place, which is 100 over e to the 2b power, and then that's going to be times, go ahead and write this in the numerator, times e to the 4b. Alright, so that's what we have after we plug in for a. Now, in order for this to simplify down, my next step is going to be 300 equals, and some of this e to the b's will cancel, right? So if I have first of all, we still got 100. But I have e to the 4b and e to the 2b, right? And so what that means is, on the top, if I were to expand that out, then that would be e to the b times e to the b times e to the b times e to the b. And on the bottom, I'd have e times the b, e to the b times e to the b. Well, two of those would cancel and just leave me with e to the 2b on top. Alright? So that's what we're down to now. The next thing I can do is divide both sides by 100. And then I'll get 3 is equal to e to the 2b. Alright, so remember, what are we trying to do here? We're trying to solve for b so that I can take it and plug it back into that first equation. So in order to finish solving this thing for b, what I'm going to do now at this point is I'm going to rearrange it from exponential form and put it in logarithmic form because I need to solve for b. So I need to get the b out of the exponent. So one way that we could do that is by turning it into natural log. So again, remember, when you rewrite this thing into a natural log format, then if I write it as natural log, then its natural log is automatically base e, okay, of this number 3 equals to the exponent, which is 2b. All right. So remember, this is your base, this is your exponent, which is 2b, and this is what it's equal to, 3. All right. So I've rewritten it now in this form. And so remember, I'm trying to solve for b, right? So what I need to do now is I just need to divide both sides by 2. And so now I get b is equal to 1/2 natural log of 3. All right, 1/2 the natural log of 3. All right, and so all I really need to do now is figure out what 1/2 the natural log of 3 is, and then I'll have the value for b. All right, let's see what it is. Okay, so I come back here. I've got my calculator up. I need to do 0.5 natural log of 3, and so it gives me 0.5493. 0.5493. Okay. All right. So that's what we've got for b. I've now solved for b. I can now take this value of b, plug it back in here, and then that will give me then an equation that I can use to solve for a. All right. So that's going to kind of be my purpose here. So now rewriting this, I've got a equals 100 over e times 2, and instead of plugging that decimal in there, I think I'm going to leave it just like this, times 1/2 natural log of 3. Alright, that looks a little bit cleaner than just plugging in a decimal that we've already rounded off, so it's more accurate as well. Alright, so now I've got a equals, let's see what kind of simplifying we can do here now to this. I know that, let's see, well, I know that half of 2 is 1, so we'll go ahead and write that. 100 over e to the ln of 3, to the natural log of 3. Alright, now remember some of our properties from the other day. Right, this is going to be 100 over e to the natural log of 3 power. Okay, remember, that's going to cause the 3 just to drop out. If you don't believe me, you can do it on the calculator. It'll tell you. Alright, and because remember, natural log and raising to the power is opposites, equals. So that's going to be 33.33. Now that's your value of a. So at this point, look what I've done. I've figured out the value of b, okay, and I've also figured out the value of a. I have those two things. So at this point, I can now take those and plug those in, right? I can plug those into the original equation, and then I've got an equation that I can use to find how many flies after 5 days. Okay, so now my equation for this model I can write as y equals, this would be, let's see, how do I want to do that the best? Probably like this. Let's say that it's 100 over 3 e, okay, raised up to the, let's see, we can raise it up to the, well, b, I can write in b, and I know b is going to be 0.5 natural log of 3 and then all that has x behind it, right? And so from here, if I take this now and plug in the correct value for x, which is 5, I'll have y equals 100 over 3 e raised up to the 0.5 natural log of 3 times, and for x this time we want to know how many flies after 5 days. And so if I figure out the value of this, I'll have my answer. And so let's see what it looks like. Y equals, let's plug it in. Alright, so again I'm back at my Desmos calculator. Put my fraction in there, 100 over 3, let's come back out, do times e. Alright, got my e. And that's going to be e raised up to the 0.5 natural log, 0.5 natural log of 3, close again, open 5. Alright, and so there you go. It's 519.62. 519.62. And then of course we're trying to answer how many flies there will be. Alright, so we're not going to say 0.62 of a fly. We're just going to round it up and say the answer is 520. Alright, so there you go. Okay. Next one. Okay, on this one it says scores for a biology test follow a normal distribution model by y equals 0.0499 e to the negative x minus 74 closed squared over 128 power. Alright, where x is the test score and x is between 40 and 100. Okay, so use the graph to estimate the average test score. Alright, so the first thing we need to do is go through and graph this thing, actually. And so it's going to be y equals, it's going to be 0.0499 e. Okay, can't see it. Alright, so e. And the e is going to be raised up now to the negative. Oops, I need a fraction, don't I? Go ahead and make that fractional power. And so it's going to be raised up to the negative. Open x minus 74. Close. Square that. And on the bottom is 128. And double check, make sure everything looks right. Believe it does. And then so there's my graph. Alright, so the graph did show up, but now here's the deal. Okay, looks like a straight line, Coach. Yeah, it does. But remember what kind of numbers we're dealing with here. The test score is going to be between 40 and 100. So I need to just kind of come on out here, take a look and see what it looks like between 40 and 100. Okay, and if I come in here and go ahead and make my attempt here to really zoom in on this thing, we're going to see what happens here in just a minute. Matter of fact, I'm going to come back over this way, pull this axis out some. Alright, so I had a point of interest there, as you can see. And so let's see if we can't hone in on that point of interest that we've got there. And as we do, what do we see developing here? Now we can kind of see where this average test score could be, because the average test score is going to be at the top of the bell curve of this thing. So remember, if you touch the function in Desmos, it gives you the points of interest, and one of my points of interest is the maximum. And so that maximum is at 74, and so in this case that is going to be my average test score. So we use the graph there to come up with that as a 74, and it is the right answer. So there you go. Alright, so remember, on some of these where the numbers are big, you may have to zoom out in order to be able to see the points that you want. And remember, when you click on the graph in Desmos, it gives you the points of interest. So if you're trying to figure out, where the point is on the graph, or how would I know to look at 74, first of all, you need to zoom out to where you can see this range that it's involved with, number one. And then number two, just click on the graph and it will give you the points of interest. And that average test score, or the average of whatever the scenario of the problem is, it's going to be at that maximum point. Okay, so that's what you're looking for. What about the next one now? Let's take a look at it. Alright, so next one says the demand X for a 32-inch plasma television is modeled by this equation, right? And so what we've got is the questions that they're asking. It says, what should be the price to sell 1,200 TVs? Okay, so TVs is going to be X, and then P is going to be the price. Okay, so let's go ahead and plug this into Desmos. Yeah, Y equals, can we see it? Nope. Okay, so Y equals, okay, we got 500. And now we really need to make sure we type this in correctly, or it's going to mess up all of these questions. Open 1 minus, alright, now we need a fraction, and so let's go with divide. On top we're going to have 4, nothing to that. On the bottom, if I can ever get it there, there we go, finally got it. Bottom we got 4 plus E, there's E, and E is going to be raised up to the negative 0.0. So let's see if we're going to get to where I want it. There we go. 0.000. That's 3 zeros, and then 5x. Okay. Alright, so there's my equation, and I have it now plugged into the graph. And again, well, Coach, there's no graph. Where is it? Okay, so once again, look at the numbers that we're talking about. Okay, selling 1,200 TVs, selling 500, selling 2,500, selling 8,000 TVs, right? And so obviously, I'm going to have to zoom out to see anything. Alright, zoom way out here. Alright, so now we've come across the graph. Alright, and of course we'll kind of see if we can't zoom in on the values that we want. Remember, number of TVs is going to be the X number here. And so really, instead of guessing with the graph, I'm just going to pop a table up here. And so if you press this button on Desmos, Okay, and click the table. It just gives you a table of values. What do I want? I want to know what's the price going to be to sell 800 TVs, or excuse me, 1,200 TVs. So if I want to sell 1,200 TVs, I need to price them at $603.25. All right. That price will allow me to sell 1,200 TVs. 603.25. And remember, this is a practical problem because the more it costs, the less you're going to sell. The cheaper it is, the more you're going to sell. So there's a fine balance there between, the consumer wants the price to be low. He's going to buy more then. But remember, the seller wants the price to be higher because he wants to get more per TV. So this equation is telling us, okay, if I want to sell this many TVs, what should I make the price? If I want to sell 2,500 TVs, what should we make the price? Well, let's see. So if I want to sell 2,500 TVs, I need to make the price $334.19. $334.19, which is about half the price of the other one, and I'm selling more than half the number of TVs. Alright, so this is the practicality of these type of things. The sellers can use this to maximize their profit. Okay, so they're saying, yeah, I'd like to get more per TV, but if I drop it to $334, I will sell over twice as many. And then so since I'm selling more than twice as many for a little bit more than half the price, that would be advantageous to the business. They would make more money in the long run. All right. So this is the type of thing that this problem is good for. What about if I wanted to sell 8,000 of these things? What should I make the price? All right. Well, let's see. If I wanted to sell 8,000 of these things, then I should make the price $22.79. $22.79. Okay. But remember, at that price, then the company, even though they're selling 8,000 TVs, probably still wouldn't make enough money, or the amount of money that they would selling it for this price. So this type of equation kind of helps businesses say, if they know the data, if they have the data to be able to create an equation like this, it helps them set their price to maximize their profit. Okay. Now, for the last two questions, it's kind of reversed just a little bit. How many TVs would sell at a price of $450? All right, now, unfortunately, Desmos doesn't have the ability for me to go over to the Y side of the table and just fill something in and then it backfill the X. I still have to put in X's, right? And so, really, I've got two ways to do this. I could either plug 450 in for P and solve this thing for X, which would be a considerable amount of work that I'm not willing to do right now. Or my other option would be to guess and check with the X's until I get 450 for the Y. Alright, so the latter probably would be the quickest way to do it. So 450. So I already know that 1,200 is 603, and I know that 2,500 is 334, so I'm going to pick something in between there. Let's start with maybe, I don't know, 2,000. Let's try that. So at 2,000, the price is 421. So I'm still too high there, right? So I need to try to get down to 450. Or excuse me, my price is too low. I need to get up to 450, which means I need to lower the amount that I'm trying to sell, right? So I need to come down a little bit. Let's go down to maybe 1,800. All right, so there, getting closer, but I'm not quite there. Maybe 1,850. All right, so now we're getting close. 51, 52, 53, 54, 55. See, I'm trying to hone in on 450. So at 855, that dropped me below. So I'm going to go 854 and see if I can hone in on it. So let's go 854.8. All right, that dropped me below. What about 7? That's below. What about 6? All right, so we're above at 6, right? So what about if I go 5? Oh, I'm above at 5. Huh. 5, let's see, 4, 3, 2, 1. Alright, so we're getting further and further away. So I'm below there. I lost track of what I was doing. Alright, so there's 7. Alright, so let's go 7, maybe, let's go 6, 6, 6, 5, 6, 4, 6, 3, 6, 2, 6, 1, 6, 9, 6, 8. Alright, so it's between 9 and 8. So let's go 8, 5, 8, 6. Ooh, that's pretty close. 8, 7, 8, 8. So I'm going further away now. 6, 5, 6, 6, 6, 7, 6, 2, 6, 3, 6, 1. Alright, so there we go. So there's 1 and 2, so not much difference there, so I'll go 1. And so we can see at 1854.61, okay, and again, this is number of TVs, so I should be at a whole number on this. And so since we're very, very close to 450 on this one, I know that's 1854, and I'll go ahead and 0.6, I'll go ahead and round that up to 1855. Alright, so that's how we use our guess and check system in order to come up with the answer here. Alright, so what about to sell $400? So I need to see if I can back this down to $400, which means I need to raise the number that I'm going to sell, because the more that I sell, the lower the price is going to be. Alright, so let's just go for, let's see, if I want to raise the price up something, let's go with 2100. Alright, we're not quite there. What about 2150? Let's see, too much. 2110. Alright, so now we're getting close at 2110. Alright, so let's see if I can aim in on right on 400. Alright, so 11, getting closer. 12, that's pretty close. 13, alright, so we dropped below at 13. Alright, so I'm going to go back to 12, and I'm going to say 0.5. That drops me below 0.4, below 0.3, below 0.2, below 0.1. Alright, I'm above at 0.1, so I'm going to go 0.15. Alright, 4. Oh, shoot. What did I do there? I got off of it. Oh, man, I erased the whole thing. Oh, I didn't. I'm at 0.1. 0.14, below 3, below 2, below 1, below 0. Alright, 0 keeps me at the same place. What about 0.5? Oh, we're getting close at 0.5. 0.6. Alright, so it's between 0.5 and 0.6. But 0.5 is really close. What about 0.54? 0.53? Alright, so 0.53 is really close at 400.0000001. Alright, and so we know that we can round that down 2112.10, and we'll just round that down to 2112. And honestly, I probably did overkill on the honing in on it, because once we know this number here, or really the first two decimals, we'll know whether we should round up or down. But I was just trying to hone in on it as closely as I could. And of course, we're just rounding to the nearest whole number on this. Alright, so there you go.